Hi guys, BuildZoid here, and today we're going to be reassembling another GPU. Today, a HD7950 that I've had lying around for a while, but I haven't done anything with because I couldn't take the Shroud apart. And in the end, I managed to, because like I got it off of eBay secondhand, obviously. This is a HIS HD7950 iTurbo, I think, is what they call the heatsink. Anyway, it's one of these kind of like ridiculous blower designs. It's 3 slots. Like this thing is, this is one giant blower heatsink, and yeah, it seemed to get pretty decent reviews as far as like by blower heatsink standards for noise and that kind of thing. So, you know, and I'm a like Tahiti is basically one of my favorite GPU cores to overclock. So it was just like, well, yeah. Picked one up because I'm kind of interested to see how the heatsink performs, and also, you know, 7950s are just fun to mess with, and you can of course crossfire them with like 7970s and 7990s, and so yeah, it's just like I just you know, I buy graphics cards for no good reason. Anyway, I don't know why I'm trying to justify it. It's like everybody at this, anybody watching this channel at this point should be aware that I'm gonna. Should already be used to the whole I'm gonna bring out random ancient GPUs. So yeah, we're reassembling this thing because I cleaned it out, you know, took everything apart, and yeah, so let's put it back together. I'm not sure where to start with this. I guess we could don't feel like starting with thermal pads because thing is, the card comes with this base plate, basically, for cooling the vCore VRM and the memory VRM. This down here is memory, which reminds me that, actually, I'm not going to pause the video. I'm not going to start a new take. But, yeah, which reminds me I wanted to pull up the datasheet for these MOSFETs. For, well, not even all of the MOSFETs, just the low sides, because obviously the low side is the more important one. And speaking of the low side, these suck. Okay, so at 10 volts drive voltage, these low side MOSFETs here are 3.7 milliohms RDS on. Like, there are 2 in parallel, but you can get, I'm pretty sure you can get 7950s with like 2 milliohm RDS on low side MOSFETs. So this is up there. This is not a particularly like great implementation of this PCB, because the funny thing is, like, you can get a lot of 7950s with exactly this PCB layout. So VRM, like everything, like all of the where all of the components are located, you can get tons of cards that look exactly the same. In terms of the components actually used, the manufacturers take whatever, like the manufacturers are kind of free to use whatever they want as long as it meets, you know, stock power draw, like stock power delivery requirements. So this is good enough for stock, but compared to some of the other VRM options you can get on this PCB, this is actually pretty damn weak. So yeah, that's a bit unfortunate. Anyway, one neat thing about this PCB that's kind of worth mentioning is you have these like I don't know what to call them, but basically like tin exposed power planes with just a bunch of tin on them. And the idea behind that is it slightly improves the thermal characteristics of well, basically those power planes. So, you know, the VRM, which is obviously connected directly to this through the inductors, that gets a little bit of extra cooling from this exposed metal over there, and the same goes for the VDDCI VRM over here. And this is the funny thing is, like, on so I actually used a different 7950 with this PCB design to get my first GDDR5 memory power draw, well, more like AMD memory system power draw measurements, and this is where you can really see the disparity. So this is what powers AMD's memory controller, this over here, this 2-phase. And then this down here is the single-phase memory power, because the memory controller actually pulls more current and about as much power as all of the memory chips combined, which is just like, okay, it's fun. So this is like 15 amps at 1 volt, whereas this is like 1.5 volts, but 10 amps. So that's why you get this disparity, whereas like, yeah, that's a 2-phase, but that's a single. Anyway, yeah, so let's throw the base plate on it, and obviously we need a thermal pad, but we're going to put the base plate on there first. and then I'll worry about reassembling the shroud. Anyway, so when I was taking this card apart, I had the very clever idea, in my opinion, to like scratch. Yeah, scratch the thermal pad thicknesses into the various heat sinks. So that right there says 1.5. So that means this needs a 1.5 millimeter thermal pad, which I have tons of because that's like, for some reason, that's like the more convenient thermal pad thickness to find. At least on DigiKey. So yeah, because I like buying my thermal pad in very large bulk packages because it actually ends up being a bit cheaper that way. Anyway, where did I put that brace? Actually, do I want to base it off of the brace, or do I want to base it off... I'll just go off of the MOSFETs. This, conveniently enough, seems to already... Like, this seems to be roughly the same thickness as a... Okay, it should be a bit thicker, but that's fine. You don't have to be super accurate with thermal pads, right? Like... Though I do have to make sure that we stay within the right length, because the thing overhangs, right? Like there's... I don't want thermal pad getting under the, like, spacer, like spacing on that bracket. So, yeah, I'll just go with what's already started. Why is this... There we go. It's gone. Yeah, okay. Now, for the memory chips, I know that I need a 2mm pad because I scratched that into... Right? Well, you can't see it, but that says 2M, so for 2mm. So, I don't want to unnecessarily cut too much of this. Just a little bit more. Oh, this one goes... Wait, oh, that's a 6-phase. Yeah, that's a 6, not a 7. Anyway. It won't get the memory. Okay, a little bit more. Yeah, that should be enough. Oh. Yep. Yeah, so it doesn't fully cover all the MOSFETs, but it should be fine for the most part. This one's one of like the stickier thermal pads that I have. There we go. Yeah, that looks good to me. Especially since like this PCB, now I think actually this might be why his has the actual base plate, because this PCB originally is designed to run completely heatsinkless. Like that's the whole reason why we even have all of this extra like solder on the back. That's because this PCB is designed to be used on GPUs like with no VRM heatsinking whatsoever, which is also why the VDCI is as substantial as it is because, again, like the plan for this PCB was to not actually have any real cooling. But since his, like HIS, should I refer to them as HIS or HIS? I'm going to refer to them as HIS. That's faster. So, yeah, the thing is, HIS obviously opted for the weaker MOSFET, so I guess they also went and were like, well, we're going to have the bracket, so... Or they had the bracket for structural integrity, and they were like, okay, well, now we can downgrade the MOSFETs. One of the two probably happened. So, yeah. It's a bit awkward to get on there. Man, it's ages since I took this card apart, so I do not actually remember which screws were for what. Okay, no, I can tell. I think. Yeah, okay, I have an idea. It's got to be these ones because those aren't used for anything else. And I don't really like this screwdriver is nice if I need like to crank up the torque, but it's not actually that it's not that comfortable. So we're gonna go with this one, which I think, yeah, I think that's the right size already. Actually, no, I think it's a little too small right now, but whatever. I'm just not gonna crank it down right now. I just need the plate to not like fall off, because the other thing is we need to get the alignment, which actually this is fit well. On some cards, getting the bracket aligned with the screw holes on like a brace like this sucks really badly, but no, this one looks like they actually have the everything set up properly. So yeah, this screwdriver head is too small. Actually, I think the Phillips one is on. That's oh, that's a 0. That'll be fine. Actually, that's the right one. Cool. So. Yeah, also, unfortunately for me, this card has Elpida VRAM, which sucks a bit. Well, we'll see. I have another card with Hynix, so I can actually do A/B testing where we like normalize for core clock and then crank, and I can actually like I can mod the BIOS for lowest possible. Well, you can technically punch in like completely custom timings. It's just like I can't actually be bothered with going that far or figuring out how GDDR5 memory timings work well enough to do that properly. So my plan is to basically just run the lowest lowest possible strap on each of the cards and see which one wins. Also on the other 7950, I actually have a BIOS that removes like overcurrent protection. This PCB I think has actually pretty decent voltage control support, so you get good you get memory voltage control, you get vCore control. You don't get VDDCI. You'd have to mod that. You also don't get this regulator down here, as well as actually there's another regulator over here, which I need to figure out some details about that. But anyway, so you don't get control over those, but you don't get control over those on like basically any card. So that's not like, it's not really a downside. And 7950s also, like, you can't get like a 7950 Lightning or something. So it's not like you really have like big differences in terms of overclocking support between 7950s. They all kind of suck. Well, okay, that's not necessarily that fair, but like you only get the vCore and the memory, and that like you get the bare you basically get the bare minimum. There is a vault mod you can do to reduce the LLC. I mean, to reduce the VDroop, which I do run on my other 7950. It's actually, can't remember how helpful it was, but it seemed to help. Like, I'm pretty, like, that is a mod that I am committed to doing on more cards. The issue with that mod, though, is that it screws up some of the, control circuitry for the voltage controller, so it's not really that safe. And if you screw, like, you could potentially really upset the VRM's control loop. Yeah, so thermal pads on. That's the base plate. And this does a good job of making the card like a lot more rigid than obviously just a bare PCB. I think this might even clear an LN2 pot, which this right here might even clear LN2 pots, which would be really cool. Like that, this would be actually kind of convenient to run. I wish the VRM heatsink fitting, like this right here is more of a thermal braking mechanism than an actual heatsink, because it's not exactly high surface area, so it's more like, oh, that's going to delay the inevitable rather than actually just prevent it, like prevent the overheating. But yeah, well, with my other 7950, I bolted the VRM heatsink of a 990FX Sabertooth onto it, and that worked great. VRM stayed very cool. So yeah, but this right here, this is not a confidence-inspiring heatsink if I really want to push the card. Anyway, that's this part of the card done. Now we need to assemble the shroud, which is the awful part of this. So this is a blower heatsink, so this is the actual fin stack for it. Rather different from what you'd see in most reference cards. The fins are very thick, right? Like, the right, nope. Right, yeah, so you can see how the fins are rather thick. And there's a lot of space between them. So this is like a low airflow restriction heatsink, but the fins themselves actually have, because the thicker your fin is, the better it conducts heat through itself, right? So yeah, it's kind of interesting that the heatsink here opts to basically go for thicker, less dense fins, and then also they're taller. Like this, it's not a 2-slot card, so this heatsink is quite a bit taller than what you'd find on most reference cards. Also, there's no vapor chamber in this. You just get a copper base with also this like plate here, which I'm not sure. Is it magnetic? That's magnetic. So not sure what that plate is made of, but whatever it is, it's magnetic. So anyway, you get this base plate, and that I think is soldered into the actual. Yeah, that looks like they've soldered it to the actual fin stack. So it basically just acts as like a metal version of a thermal pad, which yeah, fair enough, right? Like, the thing is, if you have like a 3mm thermal pad, it gets pretty expensive, and it's not actually like, sure, like 3mm of thermal pad is actually not that great in terms of thermal conductivity anyway, especially since like the generic thermal pads you find on most GPUs are like 3 watts per meter Kelvin, which is like nothing, considering that like even like steel will be like 10 watts per meter Kelvin or higher than that. So yeah, using a metal plate like this just as a sort of a gap fill to the actual heatsink, totally like valid valid way of doing it, because the other option is like 3mm of crap thermal pad, and that's just not going to work. Like, that's not going to work any better. So yeah, and then they just have 4 heat pipes, and the heat pipes, like this one's dented, which is kind of unfortunate. I think the 2 middle ones, yeah, so these two look like they're 8mm each, and then these outer ones look like 6mm. So this might not be that great in terms of maximum, like, thermal capacity of the heat pipes, because there is only 4 of them. And you can get 7950s to pull quite a bit of power. Like, the stock power draw rating on them is like 100... Well, it depends on if you're looking at boost card or a pre-boost card, but the pre-boost cards are like sub 200 watt GPUs. You can overclock them to like up to 3. You can overclock them past 300 watts, depending on how much voltage you're willing to commit to. So, yeah, this like the heat. Well, it's still not as bad as some of the other heat sinks you'll get. Like there's a bunch of 7950s which basically just have like a vapor chamber, a bunch of fins on that, and then a fan, and that's it. Like, so, yeah. Anyway, interesting that this is like the style of fin stack that this opts for. Also, I think this might fit Polaris GPUs. It won't fit a Vega, and it might fit. Actually, it should fit 290Xs. It'll fit 290Xs. The only issue if you try to put this on a 290X is that you have that. Cut it, like you have the raised base right here for the 7950 core, which the reason why you see this on some 7950 like Tahiti coolers is because there's sort of 2 versions of the Tahiti package. So by the package I mean the substrate and like the metal frame and the die. So there's 2 versions of this package, and there's a raised version and there's a lower version where the die, so basically raised version, you have the die is taller than the metal plate around it. And then there's the other version, which is actually more common, which is that the metal plate is taller than the die itself, which is really annoying because you basically, like, if you're mounting a heatsink with a flat base onto it, you basically have to either buy a shim, which ruins your thermal performance, or you're going to be like basically jamming a razor blade under the metal like the metal bracket, and like trying to basically delid the already lidless core, right? So yeah, that's but this card, luckily enough for me, is not one of the ones with the lower core. Like the core here is taller than the actual outer brace, so this cooler could have actually had a flat base. It could have had that, but it doesn't. So because the thing is, like, I don't think the manufacturers had much control over which variant of the package they got. So it's like, yeah, you have to design your heatsink for the worst case scenario, right? And then just kind of use it everywhere. So this wouldn't be ideal on a 290X because a 290X die would just be bigger than the actual contact patch that this offers, which, yeah, that kind of sucks. Anyway, let's get this into the Shroud. So this Shroud is actually, like, it's a pain to disassemble, but it's not actually that complex in terms of how many parts there are to it, right? So you have that. And then there's the other part, which somehow managed to disappear. Oh, I covered it with thermal pad. Okay, there. So then you have this part, which that's the actual blower. So, yeah. Unfortunately, one of the arms was cracked, so you can kind of see that I have some glue on there. Hopefully that doesn't throw off the balance of the fan too much. But considering that it was cracked when I got it, like, I'm not sure that like, it's probably an improvement, right? Okay, and this goes... Yeah, so there. And that's... Oh, I guess the idea with this is you're supposed to bolt this to the... Yeah, but the thing is, like, I got it with the plastic over here. You can see that broke off. So, yeah, that's not going to come together the way it's supposed to. I assume the idea is that you're supposed to bolt this part to this thing, and then it comes together, but... Considering the condition mine is in, we're gonna just have to, I guess, like, get everything together at once. Yeah. Because, like, this part just only has, like, one screw that actually attaches to the plate here, so, yeah. Anyway, I need to figure out which screws go into what. Because it's a bunch of self-tappers, and I don't really want to be using the wrong ones in the wrong place. Also because these have, like, these actually go over, like, where the memory chips are, so if they're the wrong screw, they're not going to be flush with the plate, and it's not going to work. Anyway, so that's one of them. There we go. You guys can't actually see anything that I'm working on, can you? Also, what is with the white balance? Like, the camera... Okay, no, that's supposed to be a slightly green, but... The copper is a bit too golden, in my opinion. Well, whatever. And this yellow is too... Yeah, everything's tinted green a bit. Oh, well. I'm not going to try fix that now. Too late. I mean, it doesn't really matter what color everything is. That much. Might also just be the screen that I'm looking at. It's not like... It's a TN panel. It's not super accurate. Especially since I can't be bothered to, like... It's one of my secondary panels, so it's like I don't actually care if it's super accurate. Wait, am I using the right... No, that is the right one. So why doesn't it want to get in? The alignment off? Okay, well, the thing is, you know, this one's not going there, because that's this broken off plastic piece right there. That's supposed to be there, but, well, that's not going to go there, because it's broken off. So it might have been the one for that side. I don't know. Let's see. I'll try a different one. I don't think it's aligned. Oh yeah, no. No, it isn't. This is super awkward to actually reassemble because it's like plastic on... Okay, screw it. I'm just gonna... Oh no, now it's going. Yeah, okay, now it's not as stiff as it was before. Okay, so that's fine, actually. This is not a... like, this heatsink not staying flat is actually kind of annoying to work with. Go. Obviously, these are going into plastic, so if you keep turning them, eventually you'll just shred the plastic and not going to be anything left. So, actually it kind of holds together, except of course you need to get that part together as well. And so this is actually the part that was really difficult for me to disassemble, is just like the screw, like that one, that one, that one, and that one. Because, yeah, like my normal screwdrivers don't actually reach down into those, well, my usual screwdrivers don't reach down into those holes. So I bought a bunch, like I bought a really cheap set of screwdrivers that could reach, but these are like garbage. So I still couldn't take it apart. So you'll notice that like this hole, like these holes look a little bit, you know, they don't look as clean as this one. The reason for that is after I realized that I can't get the screws out with the cheapo screwdrivers I bought, I basically went like, well, it's plastic, so I guess we'll just melt, like I'll just melt my way into it. And yeah, just took a soldering iron and melted the holes wider. Is basically what I did for this one, and that one. I actually managed to get this screw out with one of these crappy screwdrivers, but yeah. The other three, I ended up just melting my way through it so that yeah, you can see those actually go in there, but they don't go into that one. Like this doesn't go into that one. It does go in there, so it does reach to the bottom of that. Anyway, let's continue with the reassembly. For reassembly, these should actually be fine. Because, like, the main issue was that when I was originally trying to take it apart, like, the screws were just cranked, like, torqued a lot. Well, actually, the funny thing is with these screwdrivers, because you don't actually have, like, a lot of leverage on them, everything feels like it's way tighter than it should be. So, yeah, maybe they weren't that tight. Maybe these screwdrivers just really suck very badly. I think this hole might be... Okay, that evidently didn't go in. Man, okay, this... like, the whole thing being plastic is actually really obnoxious to deal with. I should have melted that hole as well. I can't get it out. Yeah, it missed where it was supposed to go. And now I can't get it out. That's perfect. Okay, well, we'll just do the other ones and try to realign that later. Actually, let's see. Nope. It's just spinning freely in that hole. Yeah, it's not going to back out. Nope, I'm not getting that. Oh, damn it. This shroud sucks. Like, this shroud really freaking sucks. And obvious, like, the other thing is with, you know, self-tapping screws into plastic is every time you reinstall them, you screw up the plastic more and more. So, I don't really want to be taking this apart over and over. They really should have had, like, brass inserts in this. Okay, wait. Do you not come apart now? I mean you don't. The hell? Oh, whatever, I can... Oh. I can still reach the screw I need to reach. Man, this is a thing, like, this is still probably not the worst 7000 series heatsink to reassemble. I think that I would give to the VaporX heatsinks. Those are like, the plastic on those is fit so badly that, like, I have no idea how you're, like, how anybody's expected to take them apart. Wait. Oh, you kidding me? Oh, the plastic in that area broke off as well. Okay, cool. So that's why that screw wasn't going into anything, because there's nothing for it to go into. Where did that go, though? When did that break? Is that currently in the heatsink somewhere? I can't hear any rattling, so... Did I over-tighten it or something? Oh wait, this one's... Okay, well, that just broke off. So that's great. Oh well. That really sucks, actually. Because ideally, I would have wanted the card in one piece, right? So... Man, these screwdrivers suck. They suck so much. I can't believe how much they suck. And it is the right size, like I checked. Nope, that's just not getting out of there. Oh well, it's not like there's anything anyway, so... Okay, well, we'll try to get the... Okay. Don't over-tighten it, or it'll snap the card again. Okay, I guess there is an advantage to these that it's really hard to actually over-tighten. Like, well, you can't apply a lot of force with these. Wait, am I using the right screw for that or not? I don't think I am. Oh no, it was the right one. Yeah, with this screwdriver, it's so much easier. Which also means far more likely for me to, like, overdo it and break something. Because this plastic evidently sucks. So, that's a real shame. Because it's a neat heatsink that you just don't see anymore. But, like, you know, like a custom take on a, like, oversized blower heatsink like this. Like, there's not many cards with something like that. And, yeah, it's just like, well, if... I don't really want to wreck the heatsink, because I mostly bought this for the heatsink. It's an interesting heatsink design that I really wanted to try messing around. Well, wanted to try messing around with, and it's just like, well, if I break everything, I can't really do much testing, can I? I'll have to myself. Oh man. Okay, no, that is not going in the right way, is it? That was not aligned in the slightest. Or was it? Okay. Now I got it right. Okay, so it's not that I lost the screws, it's that they just the mounting points are gone. Oh man. Like this one wants to keeps wanting to go like sideways. Which is really not... Okay, no, I'm gonna break something doing that. It's going in the wrong way. It's going in at like a really awkward angle where it's just like, yeah, it's not supposed to go in at that angle. Oh wait, no, I think this piece of plastic is actually from right here. And the piece of plastic that's missing... Wait, where is it missing? Oh no, it is missing right there. Okay. Well, managed to bolt that in anyway. Actually, we could probably put this in there as like a... I should probably put that back in there so that I don't over-tighten it, but... it'll be fine. We'll just leave it like this and hope that it doesn't break itself more. Okay, now we need 2mm thermal pads for all the memory chips, and then we're done. So these are already like, this right here is already like memory chip size-ish. Again, I'm not too fussed on the accuracy with the thermal pads. Now, do want to check is like if it's width. Okay, so couldn't I just take the whole thing and just flop that somewhere? Like, you know, just... no, that's that's unnecessarily too much. So I will actually partition that out amongst more spots, but... Hop. There we go. 3 down. However many more to go. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, some of those are going to be really small. One, 2, 3, 4, 5, 6. Oh man, that's a lot of... I'm gonna need to buy more thermal pad. When I got that sheet, I was like, whoa, it's so big. It's gonna last forever, right? Nope. I rebuild a lot of graphics cards. I rebuild too many of them. I'm not that far off on the sizing. Probably because I rebuild too many GPUs. So at this point, I just have a rough idea of what is memory chip shape and what isn't. And one more. Okay, that one's a bit oversized, but whatever. Go. That's all the thermal padding done. I just need to take off the protective film on them and pop some thermal paste on the heatsink, and then we can put the card back together. And will I boot it or will I not boot? I don't think I'll boot it. I can't believe this took me 43 minutes. Oh, I guess I spent a lot of time messing around with the plastic on the stupid thing. Yeah. I mean, on this, on the Shroud, it's right in front of me. Also, I really want to know if, like, this camera angle works or not. Because the thing is, it's just, like, I don't really... Like, I don't feel like clearing off my desk every time I just want to rebuild a card, just so that I can make space for the tripod. So, it's just like, is this angle terrible, or is it not that bad? Is something that I've been wondering. Because obviously, I don't really, like, well... I don't know what people actually expect from my videos, so... You know, that's kind of that. Very hard to know if it's like, am I below my unusually low quality standards, or am I above them? Nice thing about having this raised portion, though, is it makes, like, figuring out how much thermal paste you need much easier. And puts less of a mess on the PCB of the card. There we go. So, now the thing is if I'm not mistaken, this end is actually still lower than the PCIe bracket at the end. So we do need to have this raised up a little bit when I reassemble it. And then for the pressure, we just have some spring-loaded screws. So theoretically, you could add like washers to try get more mounting pressure on this heatsink. Oh man, I like it when they have the screw holes into the heatsink actually go through the PCB, because it makes it much easier to keep it aligned. You know what? I should just like put like an outline on the desk of like where the camera is pointing, so that I don't have to think about where the camera is relative to me. I can just look at if the thing I'm holding is in the square on the desk. It's actually a great idea. I don't think these are very high pressure. Like this doesn't seem to be particularly high pressure mounting hardware right here. I might actually throw washers on this during testing, because these springs don't, yeah, these are really soft. And they don't even get compressed that much. Because obviously the screws don't like have a thread all the way to the head, so stop. Let's check. So one thing I'm always concerned when reassembling GPUs is making sure that, like, because what you can run into is if you have a heatsink like this, if you put on thermal pads that are too thick or just not squishy enough, you'll end up with the core actually not touching the base of the heatsink, because the thermal pads are lifting the entire thing, and the mounting like the screws aren't strong enough to overcome the resistance to squishing of the thermal pads, right? So that's always a concern I have when reassembling cards, is just like, but are the thermal pads too tall? And then the other concern is like if you have two tall thermal pads and you crank down on, say, a base plate or something, and you bend the PCB really badly, then you're just going to kill the card as well, because you can just break the PCB doing that. Yeah, that's rebuilt. And I just realized that I don't actually have a system with an empty PCIe slot available, so yeah, I guess I'll just drop a comment if this thing actually works or not. So I'm going to do one last check. All the screws are as tight as I want them to be. Oh, this one's loose. Actually, that one just seems to be... Okay, nope, it was loose. I was kind of worried it was just free spinning, but nope, it was just loose. Okay. And those are good. Good. And yeah, those are fine. I mean, I already did those once, so I'm not going to check them again. So, yep. I kind of wish the sticker hadn't peeled off when I got it, but because it does look rather plain. I'm not really a fan of like the black with one blue thing aesthetic. Also interesting that like the fan, like when I first saw these cards, I thought like the fan was just huge, right? Because like the card's so freaking tall. But actually, no, the fan's not actually that big. They've just kind of put like I think this fan would technically fit onto a dual slot card if you wanted it to. Um, they just decided to put this massive gap so that it can actually intake air from above and from below, right? So it'll pull in air from both sides instead of being choked on one side. So because that kind of helps with the cooling performance of this design. The other noteworthy thing is that like with a lot of blowers that you get on like reference cards, they'll be like sealed all the way up to the actual bracket, right? Like all the way up to the bracket right there. But you can clearly see here, this is open, right? So it's just like if not enough air is making it out the rear end, it's just going to blast it out into the case. So I don't think that it's fair to consider this like a proper blower heat. Like it's not a full blow. Like it's not going to perform. Like it's not going to do the same thermal containment of your GPU as like a reference blower heatsink, which I think is also part of why this apparently performs really well in terms of cooling. Is just like because one of like the issues with heat, like the whole thing with a heatsink is just like you need to cram as much air as physically possible through that fin stack as quickly as possible. The more air you can cram through the fin stack, the better. Now, you know, the sort of the cheat to do like the thing that all of your axial cards do is they'll just make the fin stack bigger and shallower, so it takes less time for the air to pass through the fin stack because you're using the largest cross section. But in a blower card, you're trying to ram the air through literally the thinnest possible portion of the fin stack. So you basically have like it's a relatively high flow restriction because it's also really like the fin stack's really long. And so yeah, I guess like they're kind of cheating with the whole. It's just kind of like, you know, it should be sealed all the way to the end if you want all of the air to actually go out the end, and they're just kind of like, nah, we'll just let it kind of blast out the sides. Well, once it passes through this area, it's just blasted anywhere. So, interesting. Like, I'm interested to see how this actually performs. Even though I have to say that reassembling this shroud sucks. Also, when I got it, before I cleaned it, well, actually, when I first finally got it apart, the fin stack was actually absolutely jammed with dust. So, yeah, I don't know how long the card's been running for, but obviously, like, this heatsink does need actual, like, there's no advantage to, like, actually, I think this probably might get jammed with dust faster, or at least be more affected by it, because, like, it was basically a wall of dust when I took it apart. Which I guess would come with the fact that you need a relatively high airspeed if you're trying to get a lot of air through a heatsink like this. So, like, you'd basically be pushing the same like, if you have the same volume of air spread across, like, this much area instead of, like, this much area, right? Or this much area. You don't... Like, all of that dust that you have in this, like, that would be spread across this much area is now spread across this much area, so it'll jam up much faster, I guess, in theory. Don't quote me on that. I'm not, like, I don't do fluid dynamics. So, yeah, but this thing was jammed with dust when I got it, which might just mean that nobody's cleaned it for ages and ages and ages, which wouldn't surprise me considering what a pain the shroud is to disassemble. So, yeah. Anyway, it's rebuilt, so... I'm gonna test if it runs, and it did run when I first got it. Like, I didn't run it very long, I just kind of booted it and was like, okay, it works, because the thing when I got it was just disgusting in terms of how much dust there was. So, yeah, I didn't really, you know, didn't play with it, because it was just like, I don't really want dust from a random, like, yeah, just, it was dusty and disgusting. So, yeah, that's it for this video, and somehow this video is, it's funny, I did a different, like, a reassembling video for a different GPU, and that one also was like 50 minutes, and I was like, I'll do this again, and it'll be shorter. It's like, well, you failed, Buildzoid, you freaking failed. It's 53 minutes again, because the shroud on this sucks. Anyway, yeah, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I do have a Patreon where you can support me directly. There's a link to that down in the description below. And if you want to pick up, you know, instead of Patreon, if you want to pick up some like AHOC merch, like shirts, stickers, posters, that kind of thing, there's a link to the AHOC Teespring store down in the description as well. Both of those help out immensely with running the channel, you know, with making making purchases like oddball old GPUs that nobody cares about. And this one isn't even, I'd consider this an oddball GPU. Like, this is a pretty unique heatsink design, so it gets to be considered odd by my standards. Anyway, so yeah, that's it. Thanks for watching, and goodbye.